Welcome students. In this video we are going to see how to interface a 7-segment display with Arduino Uno and write a program to count from 0 to 9 with 1 second delay in it. Okay, what is 7-segment display? 7-segment display is a collection or group of LEDs arranged to display numbers from 0 to 9. And what is the use of this 7-segment display? Okay, it's a display device with minimal circuits, and it's easy to interface with any digital ICs. And a few applications are like digital clock, pulse oximeter, digital scoreboard, and health monitoring applications, and voltage, digital voltmeter, scoreboard, and a digital clock are few of the applications of this 7-segment display. In this you can see each digit is being constructed with one 7-segment display, and each 7-segment display is constructed with 7 LEDs and one dot LED. That is, here you can see LED A, B, C, D, E, F, G are the 7 LEDs. Along with this we have one decimal point LED. So totally it's of 8 LEDs, but these 7 LEDs are the major thing, so we call it as 7-segment display. And this is the way the 7-segment display is being arranged or constructed. Or here, if you see in this diagram, simplified diagram, you can see either anodes are connected or cathodes of the LED were connected to a common ground, and other leads were used to trigger the LED. So from this itself you can get an idea that there are two types of 7-segment display. One is common anode 7-segment display, another one is common cathode 7-segment display. Common anode, anode of all the 8 LEDs were connected, and connected to the plus VCC or plus 5 volt for an anode supply, and the other end, the cathode end, is have to be interfaced to the output pin of any microprocessor or microcontroller or any digital IC's output. They will be connected through a resistor. And here for common cathode it is opposite. Cathode of all the 8 LEDs were shorted together and grounded, and the anode is connected, interfaced to the digital ICs. So based on this configuration, the input to this 7-segment display varies. If I give mostly we consider 5 volt as logic 1, and if I apply 5 volt for this common cathode pin LED A, then it will glow. If I give 0 or ground, then this LED will turn off. So this way, if I apply um, a voltage or logic over here by applying 1 0 1 0 1 1 like that, if I apply, the corresponding LEDs were going to turn on. But they are not actually arranged in this way. They were arranged or placed in the package in like this. Okay, here this is a common cathode uh, type, a common cathode type. So if I apply logic 1, then that particular segment will turn on. And here if for common anode, if I apply logic 0, then that particular segment or that particular LED will turn on. If I apply 5 or logic 1, then it will turn off. So this is the idea. So we are going to interface in today's lab. We are going to interface common cathode um, 7-segment LED, and to display 0 I need to turn on A, B, C, D, E, F, and I have to turn off G. Except G, all other LEDs have to be turned on. So for that, what I have to do, I have to give logic 1 for A, logic 1 for B, C, D, E, F, and logic 0 for G. That particular pin have to receive, this particular pin have to receive 0, logic 0 or ground, and all others should receive uh, positive or plus 5 volt in order to display a 0. Similarly, for other numbers till 9, and also we can display alphabets like A, B, C, D, E, F. Okay. So now, to display this, what is the bit pattern we have to give is given in this table. Like if, as I said, here if you replace this tick with 1 for common cathode, for common cathode, a 7 segment display, tick you have to replace with 1, and this blank space you have to be replaced with 0. Or tick means high, blank means low. This way we have to uh, uh, give the pattern or logics to this particular pins. Getting into this circuit, here we have I have already made the connections. I have, what I have done is I have to interface this so each, here we have 8 LEDs, and the corresponding pin, where if you take the cursor to this in Tinkercad, you can see the pin number or pin name. Okay, so I have connected this pin through a LED, sorry, through a resistor to this pin number 11. Okay, so pin number 11 is for uh, LED F. Okay, and pin number 12 is for LED G. Likewise, pin number 6 for LED A, and pin number 7 is for LED B, and then pin number 10 for LED E, pin number 9 is for LED D, and pin number 8 is for LED C. And we are not going to use this decimal point, so I have not connected that. I have left it free, no problem about that. And two more wires also have to connect. One is the common cathode point, I have to ground it. So here to make the power dissipation properly, so they have I think they have made this uh, grouping like this segment, this LEDs were connected to this ground. No. So here the internal circuit, if you see, you have two ground in both side. In the middle pin is the common cathode or ground. So that have to be connected to the ground pin of our Arduino. And here, as I said, we are going to count from 0 to 9. For that, the code is here, and let us define it like this, so that it will be easy for us to write the program. So pin number 6 is for segment A or LED A. It is A, and likewise the 8 LEDs you can give, and in setup you have to configure them, those digital IO pins as a output pins, and then here I initialize count variable in order to hold the iterations value. We are going to display it from 0 to 9. So in order to hold the value for 0 to 9, I have this count variable which is initialized with 0, and in loop, what I have done is I have made a switch case. Hope you all know that switch case, which is similar to the syntax of C. Okay, in Arduino C also it is similar to the ANSYS C switch case. Here switch case, and in this switch case, switch case is written in the loop function, and you know that setup function will execute for once, and loop function is going to execute infinitely. In this infinite loop, I have written the switch case first. In switch case, I make the decision based on the count value. If the count value is 1, 2, 3, then it have to switch to the corresponding switch case. So this is case 0, and similarly case 1, case 2 we have here, case 3 until case 9 we have. And I have not given any default case, and simply given the break for the uh, coming out of this switch case. For each case we have given a break. Now what is there in the one case? See, it is copy paste of your previous experiment only, where we did the digital write. The first experiment, digital write, the first value or the first parameter is the pin number or name of the pin, and what value we are sending, that have to be uh, given. So here for displaying 0 except G, all other LEDs have to be in high state. So except G, all other LEDs were in high state, and I have written this pin number 13, which is an onboard LED, just to uh, blink in 1 second, or whenever it switches the cases, I want to toggle the onboard LED. So it's not required for this, so you can remove it. So here each time when it goes, each time it switches to the case, it will execute the pin it will exit that particular corresponding pins with high or low. That high or low value is applied to this 7 segment display through the resistor, so that this LEDs will turn on and off correspondingly. And next is uh, we want to make a count operation. So switch case part is okay, done. Here we have made the displaying part. So similarly you have to write the switch case for all 10 cases, and after the switch case we have this for each time when it comes, here we have to check if it is within 0 to 9 or 0 to 10, then I have to keep counting. If it exceeds 9, then I have to reset the counter to 0. See, it's going to count from 0 to 9, and again it have to start from 0 and go to 9, and again start from 0, go to 9. So that way it is going to run. So here what we are doing is count 0 to, so we have a if case uh, which will increment the count value by 1 for each iteration of the loops function. And if it reaches the maximum value, what we have to do, we have to clear the value. So again, so count value is resetted here to the 0, and for 1 second delay we have added a 1 second delay over here, and this again is for I have added for debugging purpose. We don't have to use this, it's okay to leave it free. So let's run this code and check the output. So you can see that it's counting from 0, 1, 2, 3 until 9, and after 9 it resets to 0, and it again starts from 0 to, it runs from 0 to 9. Okay students, that's all for now. If you have doubts, we will discuss in the discussion session.